Hi, I'm Jonathan Oxer, and this is SuperHouse, or maybe SuperHuman. A fairly common opinion about home automation is that it's just toys for rich, lazy people, and a lot of the time that might be the case. I mean, if you have electric blinds, and like I do in my house, the common reaction is, why do you have electric blinds? Like, you can just walk over and open and close them. You're lazy. Now for me right now, with my current state of physical health, that's true. I could just do a lot of things manually, physically, that I currently do using my home automation system. But for many people that's not the case. I have a couple of friends who are twin brothers with Duchenne muscular dystrophy. They're confined to electric wheelchairs, which really limits their ability to interact with the world around them. Over the last few months I've been working a lot with my friend Nick, working on projects that will help him to interact with the world more. For example, on Nick's wheelchair he has this little joystick, which is a very low force joystick. It only takes about 10 grams to deflect it, and it's very small travel, very high resolution. So this is mounted on the wheelchair and connected to the control system so that he can then use this to drive the wheelchair around. Now what would be really handy is to allow him to use a specialty input device like this, which he can manipulate so that he can use this to control the physical world around him. It shouldn't necessarily be limited to just controlling his wheelchair. Now a lot of assistive technology like this is proprietary. There are specs that are very hard to find if they're published at all. So it's been quite a challenge to try to interoperate with this. This is a Hall effect joystick, so that's why it takes such little force. It's just measuring the magnetic deviation caused by moving this. It's got a special interface. It looks like a serial port on here, but it's not. This is a port that's designed to plug into the control system of the wheelchair so that you can then use this to drive it around. So what we've been doing is figuring out how this control system works, and we've made a little dual input breakout box. It's got inputs for 2 joysticks, so we can have 4 axes, 2 axes on each joystick. And then what we can do is read the position of the joystick and either send it on to the chair so that the joystick can be used to control the chair as normal, or flicking a switch and we can redirect it. So this is an output which we use to generate PPM, which is the signal that's used for radio remote controls in the trainer port. So what we can do with this is plug a remote control into this for a drone or a remote control aircraft or an aeroplane or something, and then Nick can use his wheelchair controls, which are already set up for him, and the signal can be redirected to the remote device, and that way he can control something just by sitting in the chair. Now at first you might think that projects like this don't have anything to do with home automation. I mean, they're cool and it's a good thing to do, but where does home automation come into it? Well, the way I see it, home automation is not just about remote control toys for rich, lazy people. It's really about using technology to give physical control over your environment, which is far more than just home automation if you think about it that way. So for people who are in a situation where they are physically restricted from doing things, we can use technology to expand our capabilities. So most of the rest of this video is actually going to be a conference talk from a few years ago. This was 2011, I think it was, so 7 and a bit years ago, where I did a talk about using technology to give yourself Jedi powers. And the basic premise was, we all want to be a Jedi or a magician or whatever and be able to control the environment around us. The same technology that we use in home automation and the projects that we build can allow us to reach out with more than just our own physical hands. And then we can control things around us. So this conference talk has a whole lot of demos in it. There are some pretty fun things in there. I hope you enjoy it, and I'll see you at the end. Great, thank you. Now for all of us, there are certain moments in our lives that change the way we think about things. There are certain defining events or bits of wisdom that are imparted by other people. They either make us look at things differently to the way we did before, or they reinforce our existing beliefs and make us more sure of ourselves. And for me, one of those events was in a home economics class in year 7. And we were given an exercise of designing an optimal kitchen layout. And so we had to work out the position of the stove, position of the fridge, where the workspace would be, all of that sort of thing. And then we had to do a bit of time and motion study. And this was the first time I'd ever been exposed to this concept, and the whole idea of usability and thinking about how things are arranged for optimal efficiency. And it was a silly little class exercise, like over in half an hour, but it was one of those things that stuck with me, and it's led to what some people would call probably rather obsessive behaviours. For example, when I'm loading the dishwasher, I always pre-sort the cutlery because it's faster to do that than to sort it when you're taking it back out. And when I'm putting times into the microwave, I always do multiples of 11 seconds because there's less seek time on the keypad. But there's actually another reason for that. There's a double reason. My previous microwave, yeah, OCD, yes. My previous microwave had a feature where when it had finished cooking, it would continue turning until it had returned everything back to the front. It had about an 11.4 second cycle time. So what happens is if you put in, say, 20 seconds, you've got to wait 2.8 seconds from the time it cooks to the time it says it's ready. Whereas at 22 seconds, you've only got to wait 0.8. So it's much, much better. So my very first LCA was not far from here at UQ. And one of the keynotes was Mishi Henning, who talked about computing fallacies and usability and all of the stupid things that are done when people really should know better. And one of the things he brought up was this issue of user interfaces in the real world, physical environment, so natural interface. And the obvious one is door handles. I mean, a door is something that we go through dozens of times a day. Why should we need instructions to know how to use a door? That's just stupid. And so the question that he put to the audience was, what is the optimal design for a door that you've got to push to go through? And so, someone give me an answer. Plate. Yeah, a flat plate, exactly. So I was already thinking along these lines when I saw this keynote back in 2002. So it sort of reinforced my obsession with this sort of thing. And over time, I ended up with sort of mantra, which is the best UI is no UI. Everything should disappear and it should simply do exactly what it is meant to do at the right time. It should not necessarily take conscious thought to make something behave in a logical way. Objects should be context aware and they should be intent aware. But of course, that's really, really difficult to achieve. So one of the things that I did, and this comes back to the door example once again. Okay, think about a door. So Mishi's example was the best interface for a door is a flat plate. So you simply push it, it's unambiguous. But if you think back more fundamentally to what a door does, think about all the states it needs to be in and the reasons it should be in that state. If I want to walk through it, I want the door to be open. I shouldn't have to do anything, it should just not be there. If I'm not walking through it and it's windy, I want it to be closed so that dust and the neighbour's cat don't come in. And if Joe Burglar comes and tries to open the door, it shouldn't open for him. So it should be open in some cases, closed in others, locked in some cases, unlocked in other cases. Or maybe it's in the evening and the air in the house is hot and outside it's started to cool down, so you want the door to be open to allow a cool breeze to come in. All these sorts of scenarios. But the door itself should be able to take care of this. You shouldn't have to think about it. So one of the things that I set out to do was to remove keys. I wanted doors to simply be unlocked when I went through them and to be locked whenever anybody else tried to go through them. Now, I'm not going to dwell on this because I've already done lots of talks about this sort of stuff. So a few years ago, I implanted an RFID tag in my arm, partly to experiment with this sort of thing, partly also to figure out some of the exploits and things associated with it. So the end result is that, for me, my front door is unlocked all the time. I can walk up to it empty-handed and it just lets me in. For other people, it happens to be locked. So I won't go into that in any more detail because a lot of you have already heard me talk about that. But one of the interesting little side stories is that there's some really cool stuff on eBay nowadays. A friend of mine a few months ago bought an ultrasound machine on eBay. So he set it up in his garage. We have a nice little surgery in there now. And And so, of course, we go into his garage and just scan random things, see what we can see. And so this is a scan of my arm, and the crosses up in the top show the position of the RFID tag, which is just under the skin. So that was verifying, yes, it really is still there. It hasn't gone away. But on the theme of things behaving automatically, some of you may remember, how many people were at the Myth TV mini-conf a couple of years ago? Oh, a few of you. Okay, I did a talk there about presence awareness for Myth TV. And I'd done a little experiment at the time where I had an infrared badge, like an infrared transmitter that sent out a beacon. So you clip the badge on, there's a receiver at the TV. If the TV sees the receiver, then it knows you're there. And if you stand up, walk out of the room, TV pauses. And you can extend that a little bit further and have follow me as well. So you walk out of one room and then into another room and your show pops up on the TV of the room that you walked into. She thinks it's pretty cool. But it's got a few problems. Firstly, sticking a badge on is just naff. It's stupid. And at the time, I said I wanted to experiment with a bit of face detection and things like that. So I've been doing that, and it actually works pretty well. There's little webcams sitting up on top of the TV. And this is, once again, an example of the environment around you simply doing what it should do without you having to decide, I am going to pause the TV, or I need to do something to make it behave the way it should. And so let's try this out. This is probably going to be one of those big demo fail moments, but hey, that's what makes this fun. So let's stick up a movie. Now, normally I do this with Myth TV, but I don't have Myth TV on my laptop, so I just run up MPlayer. And when I was trying this earlier, it was having a hell of a time with the lighting conditions in here, so we will see what happens. Hang on. Okay, so what we should have now, bring that to the foreground, is if it sees me in front of it or if it detects any faces, the movie should play. And if I walk away, it's probably going to detect faces and random patterns on the wall now. Then the movie pauses. And it requires a number of consecutive frames. So I've set it up with several consecutive frames so that false positives don't trigger. At the moment, it's triggering like crazy in this room, but it actually is not that bad in the lounge room. You make it say as you wish. Inconceivable. So that actually works okay. So this is just one of the little things that I've done experimenting with trying to make the world behave the way it should. And so there are all sorts of sensors and control interfaces and things like that that you can bring into use. And part of the point of this, and this is something I've said in previous talks as well, is to think of everything as modular. So think of the world as Lego. You can have a whole lot of different actuators, you can have a whole lot of different sensors, you can have different ways of controlling things. And once you start putting these various elements into place, you can then tie them together in new ways. So if you already have an actuator in place to control something in your physical environment, if you dream up a new way of controlling it, it's then a relatively simple thing to tie it together. And then you can get different behaviors. And one of the most interesting things to come out recently, I'll tell you a little story about it. So a long time ago, in a universe far, far away, a powerful empire had plans for a new game console, peripheral. And this thing is actually really, really cool. I mean, I know at this sort of conference, there are people that like to bash Microsoft, but in this case, they have built some amazing hardware. This stuff is really, really cool. What they've done is taken technology that was previously only available to researchers at a very high price point, and they've produced it literally in the millions. I think they sold 1 million in the first 14 days or something. And that's pulled the price point down to the point where research equipment that you used to have to spend many thousands of dollars for, you can now get for $190-ish, and you can walk into a store and buy it. And it's got some really interesting stuff in it. There's an accelerometer, which may sound kind of stupid for something that you stick on front of your TV and never touch, but there's a reason for that. There's a pitch control servo, so it can adjust its angle. And the idea is that you can put it down and it will self-level. So you can also have it track faces and things like that. It's got a 640 by 480 RGB camera in it, so you can do regular video pickup. And it also has a 4-way microphone array, which in itself is really interesting. I haven't done anything with this yet, but it has a lot of potential. One of the major problems you have when you're picking up audio from a large room is that you get everything. You get the echoes, and you get ambient noise, and you get multiple people talking. So if you're trying to do, say, voice control, or if you want to have a Skype conversation with someone on your TV and you're standing there talking to them and someone else is talking in the background, you get all sorts of problems with sound. Sound is one of those things that is really, really hard to do right. I mean, Julian, I'm sure, would agree with me on this one. But people underestimate how difficult it is to get audio working correctly. What they've done with this is put in a four-way microphone array, so they can actually do spatial analysis of the sound and distinguish the position that the sound comes from in the room and cancel out everything else. So what they could do is use the position derived from things like video sensors and the depth sensor, and then ignore sound that comes from anywhere else. So you could stand in a noisy room and talk, and your voice would be picked up clearly. It also has an IR camera, which is 11-bit, so 2048 levels, and a structured light IR projector. And this is where stuff gets really, really interesting. The way this works is a little bit like radar. It's a technique called LIDAR, so it uses light instead of radio waves. But instead of using time to reflect, like radar, what it does is use dispersal of light pattern across a surface to detect distance and deformation. So the way to think about this is imagine that there is a grid of little coloured dots, infrared dots, being projected out from this in a cone. And as the dots strike objects that are further away, they'll be further apart. And so with the infrared camera, by doing analysis of the position of the dots in the image, it makes it really easy to get the distance to any object that is in front of the camera. And that is really cool. So let's try that and see how it works. Did I get... Yeah, okay, so... Actually, no, I'll tell you, before I get to that, I'll tell you a little story about how the drivers for this came about, because it is actually kind of intriguing. November 4th was when this was launched. And on the day it was launched, Lemore Fried, who many of you will know from Adafruit, which is a little hardware company in the US, thought it would be a cool peripheral for robotics projects. So she bought one and ran a USB packet sniffer on it and thought, yeah, this looks like it's got some good stuff in it, but I don't have time to write drivers, so I want someone else to do it. So later that day, she published the packet dumps, and this was at 3:40 p.m, and offered a $1,000 bounty to the first person to release an open source driver for it. CNET got on the case really, really fast, called their local Microsoft rep, and they made a statement 20 minutes later saying, Microsoft will continue to make advances in these types of safeguards and work closely with law enforcement and product safety groups to keep Kinect tamper resistant. Okay, so they don't want anybody messing with their stuff. So an hour later, Lemore increased the bounty. And over the next couple of days, there was a bit of discussion about it, and she thought about the implications of, okay, she's putting up money for someone to reverse engineer something, and Microsoft really does not like this. So she increased it again. This was after the US launch on November the 4th. What happened next was that the European launch was scheduled for November the 10th. And on November the 10th, they went on sale in stores in a number of places, including Spain. And this pleasant-looking gentleman named Hector Martin walked into a store about 9 o'clock on that morning, and he's a pleasant-looking chap. But he doesn't actually own an Xbox, he just wanted to buy the Kinect. But what he is one of the members of the group that reverse engineered the Sony DRM on the PS3. At noon, he published video proof and source code of a working driver. So later that day, Lemore says, you've done it. And not only did he get $3,000, she decided that because of the threat to people's rights to reverse engineer and to develop interoperability with existing products, she donated an extra $2,000 to the EFF. So then Microsoft made a statement saying the interface was open by design, and they were inspired. Okay. Of course, it's a big company, they don't talk internally and stuff like that. But I thought it was, when you look at it as a microcosm like that, it's quite an interesting little sequence of events. So this is what it actually does. What we're looking at here are the two video streams. One on the left is the depth camera, one on the right is the RGB camera. And there are some really interesting things you can see out of this. What this is doing is applying false color mapping to the depth values that are coming out of the camera. So the closer something is to the camera, the hotter it is. Now there are a few things you'll notice here. If you look at my hand, for example, in that picture, it's reasonably close in color to the wall behind me. And you also notice that there are things like a hard line intersecting fingers. So if you are applying edge detection algorithms and things like that, they have a bit of trouble with the RGB image. So one of the interesting things about this is not just that it allows a whole new class of approaches to solving problems, but it means you can take existing problem-solving approaches and things in OpenCV, for example. Instead of throwing the algorithm at the RGB values, throw them at the depth values, and all of a sudden it works really, really well. So as you can see, edge detection is a piece of cake when you're dealing with the depth values. So I'll fire it up and we'll see it working for real. So as I get closer, you can see it gets hotter. Hey, let's have a look at you guys. Hey. At this sort of technology, 6 months ago, you would have been paying many, many thousands of dollars for something that could do anything even remotely like that. So that is really, really cool. And what I'm running right now is the example application that Hector released as part of his, that runs with his driver. So this is with the open source driver. So what I did was started mucking around with things like hand tracking and mapping 3D zones in space to various actions. And it can start bending your brain a little bit. I'm not used to dealing with these sorts of things, so it was quite a stretch for me. But basically what's happening is that the camera itself is outputting, like if, for example, you run a hand tracking system, you end up with X, Y, Z coordinates of whatever your point of interest is, so say your hand. But they are projective coordinates, they're not absolute coordinates. So if you think about a room being a cube with X, Y, Z axes on it, it is not an absolute position that's the same everywhere throughout, or a scale the same everywhere throughout it. Because what we're looking at is a conical field of view, well, it's actually a slightly flattened cone. An X value, which is the horizontal value, will be a different offset depending on how far away you are from it. So an X offset on the edge of the field of view will actually move in towards the edge. So when you start defining volumes of space, it can become a bit brain-bending. But I drew lots of sketches and worked out some positions and played around with it. So just as a demo of this, we've got a thing hooked up. This is another major opportunity for demo fail, so this could be fun. So what we're doing here is I'm running the hand tracking software, and there are a number of points in space, and be careful not to walk in front of it right now. There are a number of points of space that have been defined as having different meanings. When it detects one of those events, there's little, it's a loop basically which has a little state machine in it. So when it detects a transition of, say, your hand moving into a hot zone, it then sends a network connection, which is going through at the moment to Andy's laptop sitting down the bottom there, which is associated wirelessly with the parrot. So if I'll angle that up a little bit. What do I have that I can sit it on? Pen will do. I think the self-leveler ran and mucked it up. Okay, so see if I can get it to detect my hand. So I can now send an up command and push. Come to me, my pretty. in practice, we got it to work about 1 time in 10. I had no expectation it was going to work. Actually, I'll just go back on that one. No, back. Okay, so one of the problems that you have, what you would have noticed is that when I was doing this, I was looking back at the computer screen the whole time. And I was watching what you were seeing, which was the position that it was interpreting my hand as being, and trying to figure out where my hand is relative to those hot zones in space. Because the thing is, if you wave your hands around, you go into a hot zone, like you have a transition into it, it sends an event. That is really, really annoying. And something that I've discovered as soon as I started playing with this is that it's hard to have any sort of interface that doesn't give you any feedback. Like we're used to either physical feedback if we're dealing with physical devices, or with some kind of visual feedback if we're using software, or maybe Audible or something like that. And so over the Christmas holidays, I was relaxing and playing with the kids' Christmas presents, and getting inspiration. And one of the things I realized is that in a computer game, they often highlight, for example, if you're running through a virtual environment and there are multiple objects that you can have an action on, then when you select it, often it will have like a blue glow or something, so you know, okay, that's the action, that's the object I've selected, so I can open that door using the force, and then I can run through and zap all the guards. And so I decided that it was worth giving it a go. I would try to replicate that sort of visual feedback, but in the physical world. So because I've already got a bunch of things at home that are connected to actuators and the home automation system, I set up some high-intensity blue LEDs so that if I select an object, the object glows blue, so I can tell what I've selected. Slow curtains, yes, I know. This was one of the other things that... Playing with the curtains. So what you're actually looking at in that last little demo of the curtains is the Kinect connected to a machine running Ubuntu, which is talking via the LAN in my house. And I have an Arduino compatible board called a 2010 and an Ethernet adapter on it, which is using power over Ethernet, and that's embedded basically outside the wall where the curtains are, and it's exposing a web services interface. So when the Ubuntu machine sees an event, it can then just sends a connection to the web services interface, which then fires off the appropriate physical actuators. And I have it connected to the high-intensity blue LEDs above the curtains, and also to big 240-volt relays that fire the curtain motors, so they control it to run up and down. And it's got a feedback mechanism and timers and things like that, interlocks built into it. So you can't make a mistake like I did originally and try to activate both up and down simultaneously on the motors. They don't like that. But there are big downsides to this. There is a problem here. Well, there are several problems here. Firstly, pretty, isn't it? It doesn't exactly blend in with the decor. The other big problem, of course, is look at what's invisible in the mirror there. So you're sitting on the toilet and you're looking at a camera. And it doesn't matter if you explain to people that there is no human watching this video stream. There is a computer analyzing the scene and doing stuff. It still just creeps people out. So, yeah, that's not so good. There's some other stuff in that picture that I've also linked up. We have a just-in-time hot water system. So it's a hot water service that you punch in the temperature you want and it comes out at that temperature. So what I've done was got an extra controller and I've hacked into it. And once again, I've got a little Arduino and some relays controlling it so that instead of having to go over and set the water temperature, I can do things like have the Kinect determine if I've walked into the shower. So if I go to the shower, it goes, he's going to have a shower. I'll set it to 42 degrees and the temperature changes. So all sorts of different things like that you can do. There are other sensors as well that I've been playing around with. I mean, the Kinect is really cool, but there are lots of sensors that are much simpler and that don't draw about 2 amps and don't freak people out looking at a camera. Things like IR range sensors are fantastic. I've used a heap of these. They're only a few dollars each, and it's a reflective sensor. So what happens is that they're quite small. You can attach it to something or hide it behind something. And it'll give you a reading which is proportional to the distance of whatever object is in front of it. So I can do things like attach that to a surface, and then you wave in front of it, and it detects your hand has passed in front of it, and you can then trigger off actuators to do things like close a drawer in the kitchen by waving at it, which is what you do with things like this. This is a pneumatic actuator. The sysadmin at the company I work at now used to work in pneumatics, and he has lots and lots of knowledge of this sort of stuff. So he arranged one of these for me to experiment with. So what you can see there is it's a bidirectional, so a push-pull pneumatic actuator in the bottom and a bunch of hose. There are some pressure bleed valves there, and the grey block in the middle with the fittings coming off it is a two-way solenoid, so I can control the piston. And you probably didn't notice, but in the previous video where we were looking at the curtains being closed in the bathroom, you may have noticed that those windows are actually held closed with sticky tape right now. That is because I'm intending to put either electric or pneumatic actuators in there, because I want to be able to wave the curtains up and then push the windows open. So, thank you very much. Yes, you have been warned. If anybody has ideas for other things that could be done with this, I would love to hear them. And there is some really, really cool stuff happening with hacking the Kinect at the moment. So there are some sites there that you can check out and see lots of cool projects and videos. There's a video, actually I'll stick it up now. There are some videos that we took this morning just in case stuff didn't work. And of course, we had stuff that didn't work. So there are a few crashes and things like that. And there's also a video up that actually did work. So I'll put those URLs back up in a moment. Yeah, there was a gentleman here.
You should hide the Kinect behind the mirror.
Yeah, a two-way mirror. Yeah, it is rather more creepy. No, it won't hurt them.
Still get you arrested.
Yes, Julian, you had a comment?
Have you added ambient light sensors so your obnoxious blue glow isn't extremely obnoxious when it's 3 a.m. and you're hungover?
I'm never hungover at 3 a.m. No, I haven't actually. At the moment, I've just got them running hard on. I could pulse width modulate them or something like that. The problem I've got is not actually turning them down. It's getting them bright enough to be seen in daylight. I've got some here, so I'll pull them out later if anybody's interested. But I've actually used multiple strips of high-intensity blue LEDs, stuck end to end, and angled them so they're reflecting back against the wall so that they're visible. And even then, in broad daylight, it's not really obvious when they're activated. But one thing, actually, it's quite handy having some form of illumination to walk around the house when it's dark. Oh, and this was the other video of stuff that did work. I'll show you that one as well. Any more questions, or are you ready to start hurling those tomatoes?
Have you thought some of the possible long-term consequences of things like those automatic doors is like people will forget how a door actually works? You get to a point where there is a pirate down in the house and people don't know how to get out.
Yeah, I suppose there's always that danger. Thinking forward, and this is starting to get into the realm of real conjecture here. If you take what I've been talking about to its logical conclusion, where the entire world around you simply does what it should do. We're starting to talk about things like the technological singularity here. Imagine, for example, I wanted to sit down. I should be able to just sit down and there should be a chair there. I shouldn't have to, it should just be there. And it wasn't there 3 seconds ago. There are all sorts of things that can be achieved with technology to make your world react to you. I'll stick those URLs back up. Yeah.
How well does it work in bright sun outside?
The Kinect.
Yeah, like it's IR, LIDAR.
I haven't used it outside, actually. That's a good question. I've used it in brightly lit rooms, like with sunlight coming through, and it seems to be okay in that. Sorry? Better in low light generally? Yeah. Well, one of the advantages of it is that it actually does work in total darkness, and so there are applications for it for security monitoring and various things like that that are quite cool. Yes, question up there.
Have you recently was looking at the video of the Kinect controlling a VMware ESX, and the gentleman's just like turning the EX on, turning it off, changing clusters, etc. Have you played with it with controlling software? So controlling, the hardware through software.
Yeah, I have a little bit.
Servers and stuff.
I have a little bit, and I was intending to do something for this presentation, and I chickened out because my presentation remote died during the Arduino MiniConf. And last night I was sitting there thinking, I could link this so that I could change slides. And I thought, no, I've got more pressing things to do, so I did other preparation instead. But yeah, you can basically, you can do anything you like with it. Like what Andy and I were just doing then was when it detected an event, it sent a network connection, but it could do anything you like. Yes?
Have you tried, regarding your earlier demo where you stopped or paused the video by walking out of frame from the camera, have you tried combining the two? Because obviously with the Kinect, you can have a better chance of face recognition because you can tell from context that the thing that's in the foreground is probably your head.
Yeah, in fact, I had an interesting conversation with a friend of mine. When I first got the Kinect, one of the very first things he said was, if you really break it down, you don't even need to do face detection anymore, because what you do is use the Kinect to do a 3D volumetric analysis of the room, and you have a baseline. And if someone walks into the room, it doesn't matter if they're lying on the couch with their back to the TV, you still know the volume has changed. And so you can figure out, okay, there's someone in the room. So yeah, I haven't tried it yet, but there are some interesting things that could be done with that. Yes?
So I gather that Microsoft's Kinect stuff does things like skeleton tracking. Is there any work on that?
Yeah, there are open tools for doing that now as well. I could demo that. There are a whole bunch of things. I could just play around with this while people are asking questions. How close are we on time? 10 minutes? Okay.
We have about 10 minutes.
Okay.
John, eye tracking, like I've always wanted focus follows eyeball. Can you see that being doable in the near future?
Eye tracking. The resolution is not that great. One of the things I heard was that they actually degraded the resolution because they simply discovered it wasn't necessary for the games they wanted to run on Xbox. And so one of the slight niggles about this is that this is a great piece of hardware, but it could have been just that much bit better. Maybe we'll see some more high-res ones come out. Actually, another interesting thing is that originally it's not Microsoft technology. It's from a company called PrimeSense, who did a whole lot of early work with skeleton tracking and depth analysis and various other things. And so what Microsoft have done is taken the PrimeSense reference design and implemented it. PrimeSense have now been contracted to, I believe it might be Asus or someone like that, and there is another version of this coming out developed by PrimeSense probably in the second quarter of this year. So right now this is the only game in town, but I expect that now that everybody's realizing how cool this is, that'll change pretty fast. And then we might see specs increase, we'll see greater resolution and other things. Okay. Yeah, I think that might be just one of their reference designs, but the one that they're working on at the moment is going to be, it's going to be like a mass market product. You'll be able to buy it in Kmart or wherever. I didn't know about that. Maybe they have. Last I heard was they had a contract to produce this design for another company. There is actually a skeleton tracking example here somewhere as well.
John,
Yeah.
also on I guess a similar line, can you see Microsoft building it into, I don't know, Windows Phone 8, 9 or 10, basically enabling you to do similar gestures from your mobile device? Is it like, do you know what's the processing power in the box?
What was discovered is that, I was actually just talking to Bod about this before the session. The original concept was that it was going to take an awful lot of processing power within the Kinect itself in order to do the analysis and then send the final results through to whatever device was connected to it, so the Xbox or whatever. And it was discovered that it took far less CPU power than was expected. And So they actually had provision early on for an extra processor and some other stuff directly within the Kinect to do onboard scene analysis. And they found they didn't need to, so they ripped that hardware out. And it only uses a few percent of the Xbox's CPU in order to do all the stuff that you're seeing here and a whole lot more. So it would be quite conceivable from the point of view of a CPU point of view to do this in a small device. The big problem is that these things take a lot of juice. They're actually using a lot of power. Like, I wasn't kidding earlier when it pulls a couple of amps. You can't run it directly off your computer. It needs a power booster in order to run it. So, and they get quite hot. Like, you can feel they're physically hot. There's a little fan inside it. It must be cranking out quite a lot of IR in order to throw spots of light 6 meters away and then be able to analyze it.
What's with the...
Sorry, where is this?
Over here. What's with the shadow on the false color depth? It looks like you actually have a shadow when you shouldn't.
Yes, that technically is a shadow in that it is an area that is occluded. Because what we're seeing is the projection of the points from a fixed point. If I stand here and there will be a shadow basically behind the area. Yeah.
Yeah, g'day. What's the go with the 4-way microphone array you said? Have people made use of that yet with the open source drivers, or is it still...
I haven't heard of anybody doing anything with it. I know there's been some work investigating how it works. There's been a lot of releases of the open drivers just recently, so there may be better support for it now. The early version, I don't think... The version of the drivers that I started playing with, which was right after it was released, had no support for it at all. Has anybody done anything with the microphones on this? Anyone clarify? I don't know. You're an audio geek. Okay. So audio is binary blobs. No one's been able to do anything with it, was the answer.
Hey.
Yes.
Hey, John.
Hey, James.
How is it supporting multiple people trying to interface with the same device? Are you just single-person interface at the moment, or...?
No. In fact, if I did players... Someone else, come down the front, please. Okay, so I'm player 1. I need player 2. Oh, yeah, now it's doing... Yeah, it's now doing... Uh-oh. Sorry. I think that's Andy messing with my head. So you can see it's doing a skeleton tracking of some sort here. It probably is, yes. It's very confused. So yeah, you can have support for multiple people and skeleton tracking and various things as well. Yeah, who's got the microphone? Yep. Luke.
Have you ever tried taking apart the Kinect hardware, for example, maybe looking at hacking it or repackaging the casing to suit your bathroom decor better or anything like that?
I haven't pulled this one apart. I've seen a few teardowns online. People have put a bit of work into that. There does seem to be a fair bit of space in it that isn't necessary, partly I think because they're trying to get separation for the microphones. So if it was trimmed down to just the cameras, it could probably be a third that length. Yeah, easier to hide, yeah. Okay, I think we're out of questions, so thank you very much. I hope that little talk gave you some interesting ideas about projects, and I'll probably revisit some of those in future episodes as well, show you in a bit more detail. I still haven't done an episode about my electric curtains and blinds, for example. But the main message that I want you to get is that we can use technology to allow us to do things, to extend our capabilities. Right now, I'm fit and healthy. I can get up and go over and open the blinds myself, but that may not always be the case. I mean, everybody gets old, and I'm only a car accident or slipping over in the shower away from being confined to a wheelchair myself. There's a possibility that any of us could end up in that situation. And what I've tried to demonstrate here is that technology can be used to extend our capabilities. It can be used to help us overcome our physical limitations and reach out into the world around us and control things that we may not necessarily otherwise be able to control. Now, it's been a while since I've uploaded a video, but over the last few months I've been working on projects, and there will be a number of build videos uploaded now in quick succession. Hopefully they'll give you some ideas for projects that you can use yourself. But keep in mind that my general approach to this is using technology as a building block to tie things together and to give us better capabilities. Not just home automation as a big remote control toy, but controlling the world around us. So thanks for watching, and go and build something cool.